And then we need to switch to English. So let's just get into that right away. Okay.
Yeah, sure. So hi Ulrika. So welcome to the software testing course. And you are here as a test expert, lecturing in tester. And so would you mind telling us a little bit about yourself and what you do? And yeah.
Right. I'm Ulrika, and I have worked as a tester, an exploratory tester, and right now I'm working as a programmer. And I came into testing because I studied at KTH, and all of the fellow students in my class, whenever we talked about testing, they were always saying that one thing is for sure: I will never work as a tester. And somehow, since it sounded kind of important to make sure that software was actually running properly, I got a bit curious, like what is it about this thing that they find so uninteresting? And for me, it was super interesting because exploring software, exploring a product or a system, and then seeing that something is a bit off, and then trying to figure out like what is the reason for this. And I felt like a detective trying to search for clues. Does this happen if I do this? Does this happen if I do this? And so I really love that. So my first couple of years working, I worked as a tester. But since I had a programming background, I always had one leg in the programming world, and I could also write tests, automated tests, and I could also make tools for myself to help with testing. And I finally decided I wanted to try out and see, learn more about, okay, so this is the testing part, but what makes a product, and how do you what are all the steps involved in doing a product? So that's why I decided to switch to programming since a couple of years back.
Nice. So you mentioned you've been working as exploratory tester, right?
Yes.
So what do you mean by exploratory tester?
By exploratory testing, I mean when the team is developing a feature, a piece of software, part of a system, to look at that feature and see, does it behave the way you expect it to do? So to use it, to look at what's going on with it, but also to see like how does it behave in relation to other things. So since the system is quite complex, you will end up in situations where something will affect something else, which you haven't really thought of. And there are a lot of things that you will try out, like switching languages and realizing that, hang on, if this is in Finnish, it's quite long, it won't fit on the screen. Or if I do this after the time has changed, then something else would happen, it won't work. So the exploratory testing is about finding all of those unknowns that you haven't necessarily thought about when you start talking about a feature.
So it's a little bit of finding the requirements still, right? It's not only like verifying that the requirements are properly implemented, it's also a bit of like trying to understand how this is going to be used. Or
the requirements are going to be a subset of what the feature actually needs to do, because they are only the things that we can imagine when we're sitting there and writing them down. And of course, when the software meets the real world, there are so many other things that we haven't thought about. And you will find things that are like, this is a bit odd, but you have to ask someone, do you think that this is the way it should behave? Like, is this a bug or a feature?
Yeah.
So yeah, you're exploring the requirements, but you're also like broadening what the requirements finally are.
Nice. Okay, so so what does it mean to work as a tester? What are the daily tasks that you would do?
It would usually start when someone has an idea, if a product owner comes to the team with an idea that they want to implement, or some other kind of stakeholder. and talk about so this idea, what do you mean with this? And this is something you would do together with the developers as well. And so talk about it. How should this work on mobile? How should this work on a desktop? Okay, so what if this happens? And try to help like explore different scenarios and explore requirements for that feature. So that would be like the first step of the work. And usually it's really good to include a tester in that case, because they will have like a database of things that usually go wrong. So if they will tell you that usually when you switch a language on the system, this will happen. We need to think about this in this case as well. Having that risk mitigated when you're just talking about ideas is so much better than finding it out after everything is done and programmed. So that's the first step of being a tester, like talking about things and coming up with possible problems that can arise and thinking about them ahead of time.
Nice.
And then you will usually do like try to collaborate on testing the things, running through different scenarios, coming up with new scenarios. It's a really creative work, because you need to think of like, okay, so some people are going to be like, how can I find a bug in this? And they will go like really like a bloodhound trying to find some problem, because there's always going to be something.
Yeah. So I really like the analogy of detective work. I mean, that's how I feel as a programmer also when I don't understand something. So would you agree on like testing is not only just mindlessly running the system after a script and checking the output, it's also a way of trying to communicate with the system, or trying to get feedback from the system, or build knowledge, really.
What usually happens is something that you might come upon if you work with this a bit of time, is that you will come upon people talk about testing and checking. And checking is the stuff that we usually say that computers can do. Like if you have steps that are very, very specified, there's no point in putting a human to do those steps, because they are so specified and they are so they're not subject to change. They're not subjective. So those objective things, you might as well put a computer to do those things. But then when there are things like, oh, you can't really tell that the contrast is low on this thing, you need to be a human to be able to see that this could be a problem, and to find out that this could actually be something that needs to be addressed. So that would be the proper testing, I would say. The human part, when you need to have a brain and to have a subjective idea about things.
Nice. So what kind of, if we keep in the area of exploratory testing or and not writing unit tests per se, so what kind of tooling would you use as a tester? What kind of softwares would you use? What kind of programs would you use perhaps to automate these?
For exploratory testing, or
yeah. Or
for exploratory testing, it's mostly your brain, and mind maps are a good thing, like having an idea of what you're going to explore. Because one thing that exploratory testing is not like randomly clicking around. You usually have an idea that I want to explore this feature, and I'm going to do it looking at times and dates, like how will that impact this booking feature or something like that. So that's very focused. And when it comes to automating larger things, I find that a certain amount of doing GUI tests is helpful, because there are some things that you just want to make sure are going to happen, like logging into the system. You don't want that to break. And so having a little set of those kind of tests, I find very helpful, like the really basic things that your application needs to be able to do, that you're able to do those. I would do some GUI tests for those. or some end-to-end tests in some manner.
Nice. So when you explore something and you find out that, okay, the dates are not really quite working or something like that. So what do you do with that kind of information? Now you're the only person that knows it. How do you transport that information to a change of the source code and a new release, perhaps?
I would first talk to the developers and see if they have understood the things the same way as I do. I would show them, like, this happened when I did this. Do you think this is how it's supposed to be? And if we agree that this is probably not how it should be, we would talk to a product owner. I'm not sure how much if a product owner makes any sense.
Yeah, I guess so.
A stakeholder or someone who makes decisions about what we should, what the system should do and not do. So that's a person that we would go and talk to them and make a decision together.
Okay, so it's mostly orally. You don't like write a ton of emails or produce some kind of report or something.
I don't have much patience for it, because you need to think about, okay, so how much time do you put into doing the report, and what do you get out of it, and who is it going to be for, and what are you going to do with it later on? So if you find that we're never going to look at this later on, then there's no point in actually writing it down in my I do take notes for my own sake, because it might be easier to remember what you had tried and didn't try, but I will usually not keep those for a particularly long time.
Nice. So okay, and then the programmers perhaps change, or developers perhaps change something in the system, and are they responsible to check that it works again, or what happens? Will someone regress or test this again, or would you take responsibility and do that?
I would be a bit upset if they didn't check it first, because I feel that's the responsibility. Somehow, if I've explained that this happened in this manner, I don't think that there's an excuse for them not to just try out that their code actually does what it's supposed to do. I would do that myself if it was my code, at least. But after just like after it has been verified in that sense, I would also test it again and see if there has been any other consequences, like this could have had an impact on something else that you find. Now the other button isn't working or something like that. So I would test that as well.
Nice. So you did a bit of exploratory testing, and now you transformed yourself into a programmer developer, and you don't have any specific testers in the team. Instead, everyone is a developer. Was that correct?
Yeah, that's correct.
Yeah. So how do you feel the switch from the old way and to the new way? Is things that you lack in the old way that you would like to have in this new way of working? Can we see it as an old way and a new way of working?
I think it's going to be one of those it depends things, which is so much everywhere when you work with this. Work in software development in general. We are doing a system-to-system product, or our team is responsible for a system-to-system product.
What does that mean?
That means that there's no human being integrating with our code. Or we have a very small little configuration interface with a couple of fields in it, very small. And so since there is no human being, it doesn't make as much sense to have a tester to click around. There's nothing to click around in. Of course, they could integrate with the system with code as well. But we feel that we are on top of those things ourselves, and we can do that ourselves. Because in my team, we're very good at thinking about the end-to-end scenarios, even though it's a computer to a computer talking. We think about the end-to-end scenarios. And we have relatively small pieces of code. So we have, I don't know if you heard microservices. So we have very small applications that do a little limited thing. And we do mostly end-to-end tests on those, and not that much unit tests.
So what would you define an end-to-end test to be?
I think it might be time for me to, I had this picture I'd like to show.
Yeah.
Because there's a difference between using unit tests and using integration tests. And I find that unit tests are, you're going to be testing a relatively small piece of your system. And that doesn't actually mean that you will know that everything is working. And let me show you this example to illustrate. So here we have a unit test that is passing, and that is that the lock can actually close. But if you're looking at the integration tests, I don't think that this is the intended behavior. So you could write a test for this lock and say, does the toggle work? Yes, it does, but the door isn't actually locked. And so that's what I mean, that we are mostly making sure that everything works together, that the door actually is locked, and not just that the parts in themselves are working.
So, I mean, it's like overview versus details, right? So
exactly.
Nice. So how do you define an end-to-end test? What do you do to produce one, or how do you do it?
I would look at what input do we get into the system, and so in our cases it will be we will call an API and we will get data from that API, and at our end we will output data into a database, for example, or so the end-to-end test would be to go from the absolute beginning of the system, like what do you get into the system, what are you feeding the system, and at the end, what does actually come out of it. And that can be pretty much black box. That can be just calling it, or you don't need to actually do the different parts of it. You can just, okay, so if your system is an API which will respond with data, then just call that endpoint and get data back and see what happens. Is it the correct data?
Okay, so in this case, if the data is complex, or I mean, if it's a JSON or if it's some kind of XML or something like that, do you test like everything in that you have like a template JSON file that you compare to, or do you like check one or two things in it, or do you just check that it's something is coming back fine? So how detailed are these tests?
It depends.
Nice.
But one thing that we have enjoyed doing is we have spent a lot of time working on an older system, which we are replacing with a new system. And one of the things that we have done is that we have recorded the output of the old system. And we have done the new system in parallel. And then we have recorded the output of our new system. And so instead of trying to find like all the different test cases that we could possibly find, which relate to the older one because it didn't have those written down, we just input our usual data, record the outputs, run the new one, and then compare the two files and see, okay, so do we get the same things out of these? And then we find that no, we don't. There are some things that are different. And then we look at those and we realize, okay, so we have missed this case because these come from another kind of thing.
Is that process a manual, like exploratory process also? So you're actually looking at these files?
Yes, we actually look at them, but we do build some tools. So we have a whole, we usually build a little program to do this because we don't want to look at the files. So we will build a program which compares line by line. And it can output, these are the lines that are different, for example. But then we will have to look at the lines that differ and try to figure out, okay, so why do they differ? And then the detective work comes in again. Like, okay, so this one looks a bit odd, but it's pretty long. Does that have anything to do with it?
So the comparison software that you've written, this was something that you wrote, not something that is commonly used by every company, or?
I don't think we're the only ones that do this kind of process, but it's something that's very specific for exactly this task, and we will throw that away. So we're writing a lot of software that we actually never use because they're just tools and helpers and those kind of things. We use it for a short time and then we throw it away.
I guess there must be some output out of an API that normally changes, that should vary, like dates or something like that.
Exactly.
So you config that tool that you wrote to ignore such things, or just check the data or the format of those things, or how do you handle variation?
So this is when it's a bit exploratory because you have to use your brains. So what can happen is that if some things are time sensitive, so let's say that this old system and the new system, they can't run at the exact same second, which means that the input data could be different because there might be one more line in one of the files, the one that runs later. And then that will be a difference then. So you have to look at it and you have to see like, okay, so this one, well, it did come in at this time. Could that be the reason why it differs? But sometimes you can make things time agnostic, where you just you pretend that it's a certain date, and you run them pretending that's a certain date, or those kind of things.
Okay, nice. So okay, so that was the end-to-end tests. So do you write any unit tests at all, or when do you think that it's suitable to write unit tests instead of end-to-end?
Yeah. So we write unit tests and we do some test-driven development when we are going into something. So the major part of our work is shuffling data from one point to another. But usually you shuffle the data into the system and then you look, there's a certain amount of transformation that's being done, like a tiny bit of transformation. And that's usually where like the business logic is in that part of the algorithm. And so that little business logic algorithm, that one is very suitable for being test-driven and having unit tests. And those we want to keep because that's the business logic. That's super important that it stays the same. So that's the part of it.
So, so I think that we probably need to conclude this interview. It's very interesting, but in order to have something that students that can actually look through.
Master.
Yeah. So in the end, I usually ask, is there something that you would like to say to my students that you think is extra important when they, during their studies or when they search for work or something like that?
Oh, I think that the most important thing that they can do is to learn about fixed mindset and growth mindset. This isn't
what is
topic at all. It's the difference between thinking that you are smart or not smart, or realizing that your brain is actually a muscle. And so I struggled with this a lot when I was a student. I thought that I wasn't as smart as the others. And after a while, I learned that this isn't the case. It's just that the people that I thought were maybe smarter than me, they had actually been practicing a lot more. So I was comparing myself to people who had been programming for years before actually starting to study. And I just learned programming. It was the first programming course at university was the first time I did any programming.
Yeah.
And I was comparing myself to them and thinking I wasn't as smart. But then I learned that if I practice and practice and practice, I can actually get better. And I also learned to realize that I can be good at anything, but I chose to prioritize my time. So I might not get any good at some things, but that's just because I haven't prioritized them. So fixed mindset and growth mindset, super important.
Nice. So some people say 10,000 hours or something like that to grow mastery in some task. And I mean, if you put 10,000 hours on anything, I mean, you will become an expert in that.
Exactly. And I feel talent is super overrated. Of course, talent can exist, but I think it's only a small amount of people who are impacted by talent. Most of us just
nice. And I mean, it goes pretty good along with what I say to my students. So spend time on it. Spend time on the problem. Yeah. Awesome. Thank you very much, Ulrika.
Thank you.